MIT Energy Initiative presents Responsive Design Meets Responsibility for the Planet's Future. Senior Sylas Horowitz tackles engineering projects with a focus on challenges related to clean energy, climate justice, and sustainable development. Written by Deborah Halber. MIT senior Sylas Horowitz kneeled at the edge of a marsh, tinkering with a blue and black robot about the size and shape of a shoebox and studded with lights and mini propellers. The robot was a remotely operated vehicle, ROV, an underwater drone slated to collect water samples from beneath a sheet of Arctic ice, but its pump wasn't working, and its intake line was clogged with sand and seaweed. Of course, something must always go wrong. Horowitz, a mechanical engineering major, with minors in energy studies and environment and sustainability, later blogged about the Falmouth, Massachusetts field test. By making some adjustments, Horowitz was able to get the drone functioning on site. Through a 2020 collaboration between MIT's Department of Mechanical Engineering and the Woods Hole Oceanographic Institute, WHOI, Horowitz had been assembling and retrofitting the high-performance ROV to measure the greenhouse gas emitted by thawing permafrost. The Arctic's permafrost holds an estimated 1,700 billion metric tons of methane and carbon dioxide, roughly 50 times the amount of carbon tied to fossil fuel emissions in 2019, according to climate research from NASA's Jet Propulsion Laboratory. WHOI scientists wanted to understand the role the Arctic plays as a greenhouse gas source, or sink. Horowitz's ROV would be deployed from a small boat in sub-freezing temperatures to measure carbon dioxide and methane in the water. Meanwhile, a flying drone would sample the air. An MIT Student Sustainability Coalition leader and one of the first members of the MIT Environmental Solutions Initiative's Rapid Response Group, Horowitz has focused on challenges related to clean energy, climate justice, and sustainable development. In addition to the ROV, Horowitz has tackled engineering projects through D-Lab, where community partners from around the world work with MIT students on practical approaches to alleviating global poverty. Horowitz worked on fashioning waste bins out of heat-fused recycled plastic for underserved communities in Liberia. Their thesis project, also initiated through D-Lab, is designing and building user-friendly, space- and fuel-efficient firewood cook stoves to improve the lives of women in Santa Catarina Palopo in northern Guatemala. Through the Tata MIT Grid Edge Solar Research Program, they help develop flexible, lightweight solar panels to mount on the roofs of street vendors' e-rickshaws in Bihar, India. The thread that runs through Horowitz's projects is user-centered design that creates a more equitable society. In the transition to sustainable energy, we want our technology to adapt to the society that we live in, they said. Something I've learned from the D-Lab projects and also from the ROV project is that when you're an engineer, you need to understand the societal and political implications of your work, because all of that should get factored into the design. Horowitz describes their personal mission as creating systems and technology that serve the well-being and longevity of communities and the ecosystems we exist within. I want to relate mechanical engineering to sustainability and environmental justice, they said. Engineers need to think about how technology fits into the greater societal context of people in the environment. We want our technology to adapt to the society we live in, and for people to be able, based on their needs, to interface with the technology. Imagination and inspiration. In Dix Hills, New York, a Long Island suburb, Horowitz's dad is in baking, and their mom is a speech therapist. The family hike together, but Horowitz doesn't tie their love for the natural world to any one experience. I like to play in the dirt, they said. I've always had a connection to nature. It was a kind of childlike wonder. Seeing footage of the massive 2010 oil spill in the Gulf of Mexico caused by an explosion on the Deepwater Horizon oil rig, which occurred when Horowitz was around 10, was a jarring introduction to how human activity can impact the health of the planet. Their first interest was art. Painting and drawing portraits, album covers, and more recently, digital images such as a figure watering a houseplant at a window while lightning flashes outside, a neon pink jellyfish in a deep blue sea, and, for an MIT-wide COVID quarantine project, 2 figures watching the sunset over a Green Line subway platform. Art dovetailed into a fascination with architecture, then shifted to engineering. In high school, Horowitz and a friend were co-captains of an all-girls robotics team. It was just really wonderful having this community and being able to build stuff, they said. Horowitz and another friend on the team learned they were accepted to MIT on Pi Day 2018. Art, architecture, engineering, it's all kind of the same, Horowitz said. I like the creative aspect of design, being able to create things out of imagination. Sustaining political awareness. At MIT, Horowitz connected with a like-minded community of makers. They also launched themselves into taking action against environmental injustice. In 2022, through the Student Sustainability Coalition, SSC, they encouraged MIT students to get involved in advocating for the Cambridge Green New Deal, legislation aimed at reducing emissions from new large commercial buildings, such as those owned by MIT, and creating a green jobs training program. In February 2022, Horowitz took part in a sit-in in Building 3 as part of MIT Divest, a student-led initiative urging the MIT administration to divest its endowment of fossil fuel companies. I want to see MIT students more locally involved in politics around sustainability, not just the technology side, Horowitz said. I think there's a lot of power from students coming together. They could be really influential. User-oriented design. The Arctic underwater ROV had to be waterproof and withstand water temperatures as low as 5 degrees Fahrenheit. It was tethered to a computer by a 150-meter-long cable that had to spool and unspool without tangling. The pump and tubing that collected water samples had to work without kinking. It was cool throughout the project to think, okay, what kind of needs will these scientists have when they're out in these really harsh conditions in the Arctic? How can I make a machine that will make their field work easier? I really like being able to design things directly with the users, working within their design constraints, they said. Inevitably, snafus occurred, but in photos and videos taken the day of the Falmouth field tests, Horowitz is smiling. Here's a fun, unexpected, or maybe quite expected occurrence, they reported later. The plastic mount for the shaft collar, used in the motor's power transmission, ripped itself apart. Undaunted, Horowitz jerry-rigged a replacement out of sheet metal. Horowitz replaced broken wires in the winch-like device that spooled the cable. They added a filter at the intake to prevent sand and plants from clogging the pump. With a few more tweaks, the ROV was ready to descend into frigid waters. In summer 2022, it was successfully deployed on a field run in the Canadian high Arctic. A few months later, Horowitz was slated to attend Ocean's 2022 Hampton Roads, their first professional conference, to present a poster on their contribution to the Hui permafrost research. Ultimately, Horowitz hopes to pursue a career in renewable energy, sustainable design, or sustainable agriculture, or perhaps graduate studies in data science or econometrics, to quantify environmental justice issues such as the disproportionate exposure to pollution among certain populations and the effect of systematic changes designed to tackle these issues. After graduating in February 2023, Horowitz will spend 6 months with MIT International Science and Technology Initiatives, MISTI, which fosters partnerships with industry leaders and host organizations around the world. Horowitz is thinking of working with a renewable energy company in Denmark, one of the countries they toured during a summer 2019 field trip led by the MIT Energy Initiative's Director of Education, Antje Danielson. They were particularly struck by Samso, the world's first carbon-neutral island run entirely on renewable energy. It inspired me to see what's out there when I was a sophomore, Horowitz said. They're ready to see where inspiration takes them next.